IPv6 packet. Now the problem is what is happening that because billions of devices now need to connect to the internet, we are a concept of IP, internet everywhere, internet everything, something like that, IP anywhere or something like that, which is mean that most of the even your household devices need to be connected to the internet as well. Computer, mobile, tablets, these are great and happen because we need to connect the internet, we need types. That is why the ICs are delayed. They are almost finished, right? You can see this internet routing table expansion, lack of end-to-end connectivity. That is a problem. Then what happens? We need to replace with another IP address. We need another IP address, which is called IPv6 address. And you can see as compared to where we need 4, IPv4 can give you maximum 4 billion addresses, while IPv6 can give you 340 undecillion, trillion, decillion, I don't know. But that's a unit IPv6. So because this is 32 bits and this is 128 bits. Okay. So now increase address space with the IPv4. There are two versions, IPv4 and IPv6. IPv4 is 32 bit and IPv6 is 1 bit. Today power 20 can do to power 24 or 32. The 32 billion addresses all over the world, which means basically these devices can be connected. Luckily we have private IP addresses. That's why we still are able to use IPv4. If we didn't have that private IP addresses, then might be we finished this maybe long time ago. So, but now they realize that problem and they are going. They already IPv6 are already there as well. So IPv6 is now give you more IP address space. IPv6 you can see these are the field you can see like in IPv4. IPv6 has a simple field. So this is the IPv6, a simple header. I think this is IPv4. Sorry. So IPv6 you can see it's a very simple as compared to IPv4. So there is no flags, there is no checksums. Very simple. Hop limits are there. Similar like TTL, there is a hop limit here.